Okay, let's look at how to solve this problem. I have a student that expends 7.5 watts of power in lifting a textbook 0.50 meters in 1 second. How much work is done and how much does the book weigh in newtons? Okay, so this is a two-part problem. Let's write down what we know. We know the power, we know the distance moved, and we know the time that it takes to move it. What we're looking for is work, and we're looking for the weight of the book in newtons, which will be a force. So now we know that power is equal to work over time, and we know that work is equal to a force times a distance. So let's start with power is equal to work over time. I want to solve this for work because I know power and I know time, so I can solve this equation for work. What I first want to do is multiply both sides by time so that the t's cancel, which the t's represent time. T's cancel on the right side, and I'm left with t times p is equal to w, but I'd rather write it where the w is on the left-hand side, so I can write w is equal to p times t. So now I can plug in my values for P, which is 7.5 watts, and I can plug in my value for time, which is 1 second. And I get an answer of 7.5 watts seconds. So a watt second, we know, is going to be equal to joules. So my answer is 7.5 joules. So that answers the first part of the question, how much work is done. And the next one I want to know is how heavy was the book in newtons. So I go back to my equation for work. Work is equal to force times d. But in this case, I want to know how much the force is. So I solve this equation for F. So divide both sides by d so that my d's cancel. D stands for distance. So I'm left with W over d, or the work divided by the distance moved, is equal to force. But I'd rather write it so that F is on the left-hand side. So I can write F is equal to W over D. So now I can plug in my values. The force is going to be equal to the amount of work done, which is 7.5 joules, divided by the distance moved, which was 0.5 meters. So the force is going to be equal to 15 newtons. Check for significant figures, and I can leave my answer as 15 newtons. So I know the work was equal to 7.5 joules, and the weight of the book in newtons is 15 newtons.